Hi, welcome to Nomis Academy. In this video, we are going to be looking at cycle theorems, and then we are going to consider Theorem 5. We are going to state the theorem and as well prove the theorem. So let's start. The theorem states that the opposite angles of a cyclic quadrilateral sum up to 180 degrees. Okay, the theorem says that the opposite angles of a cyclic quadrilateral sum up to 180 degrees. So I would like to define a cyclic quadrilateral. So what is cyclic quadrilateral? A cyclic quadrilateral is a four-sided shape whose vertices lies or touch the circumference of a cycle. So let's take this diagram to explain what I just said. This is the center of a cycle. So we have a quadrilateral inside, or which is inscribed in a cycle. So let's call here A, B, C, and D. Okay. Now this theorem is saying that the two opposite angles of a cyclic quadrilateral sum up to 180 degrees. That is, this angle here and this angle sum up to 180 degrees. Also, angle at A and angle at B also sum up to 180 degrees. So now let's start the proof. Let's start the proof. Okay, we are given a quadrilateral. I'm using the short form quad, A, B, C, D, inscribed in a cycle centered at O. Okay, now we are to prove that angle ABC plus ADC sum up to 180 degrees. Okay, so we have to prove that angle at B and angle at D the sum equals 180 degrees. Okay, let's look at the construction. Okay, we have to join A to O, join AO and CO. So we are joining AO and CO. So we have something like this. Okay, so we have that. Now let's continue with the proof. So the proof proper. Now we have AO and CO, which are the radii of the cycle. Now let ABC, let ABC be Y and ADC, be X. Okay, now we agree that this angle ABC is Y and then ADC is X. Okay, now reflex AOC is equal to 2x. So what should be the reason for that? We say that angle at the center equals twice the angle angle at the circumference. Okay, we also have the obtuse AOC equal to, okay, we say this particular angle is 2x, while the obtuse should be 2y, equal to 2y. The same reason, let's clean this other side. So the reason for this, we say angle at the center equals twice the angle at the circumference. Okay, so since these two x is twice of x and 2y is twice of y, then we can also say that 2x plus 2y is equal to 360 degrees. And what is the reason for that? Angles at a point. Angles at a point. So our major focus is to prove that x plus y is equal to 180 degrees. So let's clean the diagram so we can continue with the proof. So pick out what is common here. 2 is common. We have x plus y equal to 360 degrees. Divide through by 2. X plus y is equal to 180 degrees. Okay, so you remember that x is AD and y is ABC. So we can now write that ABC plus, remember y is ABC and x is ADC, sum up to 180 degrees, which is our proof. Okay, so hence proved. So this is the proof that the opposite angles of a cyclic quadrilateral is 180 degrees, or sum up to 180 degrees. Thank you for watching. See you next time. Bye.